Hey everybody, Bill Sky the COBOL guy, and we're back again for a COBOL to C and C++ function execution video. This time we're going to talk about arrays. Now, if you have not looked at the previous video on the introduction to calling C and C++ functions, I really recommend that you do that. Pretty important video, and it'll give you a lot of background for what we're doing today. In fact, what we're going to do today is build upon the program that I wrote in that previous video. So we're going to be dealing with integer and floating point arrays today, and then in a following video I'm going to show you how to do all this from C++ instead of just C. I talked a little bit about that in the previous video, but we're going to expand upon it in the next video. So let's get right to it. Okay, so I'm going to start off with the exact same code that we had in the previous video, where we created a bunch of C functions that would do things like modify strings and add two numbers together. But this time what I want to do is I want to add a couple of functions to sum up an array. So let's go in here, and I'm in the C program. So what I'm going to do is I'm going to create a function called SUMINT_array, and I'm going to send by reference, because an array, whether it's C or C++, is basically just a pointer to memory. So I'm going to get the int array, and I need an array size. You always need to do this. All right, now I'm going to create a variable that's going to contain the sum of our array, and I'm just going to create a very simple for loop that's going to add everything up. We'll close off the for, and it'll return the int sum, and then we'll close off the function. Now, what I want to do, I like a function that's going to add up that adds up integers, but what about a function that adds up floating point? So I'm just going to go ahead Now, one thing that we're going to do here is that we're going to return a double, but as I showed in the previous video on GNU COBOL, it does not do well on retrieving double floating point numbers returning from a function. I haven't done a lot of testing on floats, but on doubles you get a lot of garbage, and I'm not sure why. Maybe if the GNU COBOL developers are watching this, which I find that hard to believe, maybe they might look into it. But let's go ahead and basically do the same thing. So it's the same code, but what we're going to do is, instead of returning the double, which we're still going to have in this code, but instead of returning the double, what we're going to do is we're going to have a by reference variable called array sum. And then what we'll do here is we'll say array sum dereferenced equals the double sum. Okay? So this way we're going to modify this, and since we're not going to send it by value, we're going to send it by reference. It should work okay. Let's make sure that this all looks good. All right, looks good. Let's go ahead and build this to make sure that those functions in C actually build okay, which they do. That's great. All right. Now let's go back to our COBOL program, and what we're going to do here is we're going to actually call those functions. But before we do that, we have to create a couple of arrays. So I'm going to go up to the top here. There's a lot of stuff in here. Now I already have those arrays in there because I was testing it, but let's go ahead and code them from scratch. So I'm going to create my int array, and I'm going to say array items, array int items. We're going to say occurs 10 times, usage is binary long. I'm going to create a, then here's the key. When you send an array to a function from COBOL to C++, you don't send this array name. You also don't send this. You have to send a pointer to that function. So to do that, I'm going to create an int array ptr variable. It's going to simply say redefines int array usage pointer. So that is a pointer to the int array array. Now I'm going to create another thing here called array sum, and this is going to be a pic94. Usage is binary value 0. So that's my int array. Now let's go ahead and create a floating point array, because we're going to be doing both of those, right? We're going to be doing a floating point and we're going to be doing a integer. So we're going to call this float array, and we're going to say float items. And instead of binary long, we're going to call this comp2, because that is what a double is. In C and C++, it's a comp2. Then we're going to say float array pointer redefines float array, and we're array sum. Let's call this int array sum, and so we'll call this one here float array sum, and this will be usage is comp2. Now let's just go ahead and build it to make sure I haven't typed any bad COBOL code. I'm going to renumber this COBOL code, and I'll go ahead and reload it. All right. So there are my two arrays. There's my int array and there's my float array. I've got my array int items and I've got my array float items. All right, so let's go down and let's go ahead and call our function and see that we did. So the first thing that I want to do is I want to I'm going to do the int array first. I want to fill it up with some data. So let's go over here and I'm going to do a perform. So I'm going to say, how do I want to do this? First of all, let's do a display. Testing int, testing sum int array. And I'm going to move 1 to an int. Now an int was simply an integer variable, a 77 level integer variable. And we're going to use this for counting. And I'm going to say perform 10 times. I'm going to say compute int array items and int equals an int times 10. Just some random data. Then I say add 1 to an int. That's so I can go to the next item in the array. And then we're going to say and perform. We don't need these semicolons because we're not working in C. All right. Okay, so there it is. So that actually puts data into the array. Now I'm going to go ahead and say move 10 to an int. And we're going to use that an int to send to the function to say this is how many items are in the array. And I'm going to say call sum int array using by reference int array pointer. So we want to send the pointer to the function, not the array. By value and int. and then it's going to be returning array sum. Now let's make sure we have these variables. I want to make sure I have an int and array sum up here. Oh, it's int array sum. Do I have an int? Yep, I've got it right here. So int array sum and float array sum. It's so important to keep your naming. Okay, so we have a problem here. It says int array items is not defined. So let's see, we've got array int items. I probably would have been better if I had named that a little bit better. More consistent. I just said that too, didn't I? Okay, so let's go ahead and put that there. Okay, it builds okay. Now let's go ahead and display the results. Okay, 550. Well, if you do the math, if you take 1 times 10 is 10, 2 times 10 is 20, 20 times 10 is 30, and so forth. You add all those together, you get 550. Now, one way you can verify that is you can say display data at an int, put a space there, is so that'll actually show you the data that you're putting in the array. So there you go. So we've got 10, 20, 30, 40, 50, 60. If you add all those together, I do believe you get 550. So our function worked. Our integer function worked. Let's go take a look at our floating function now. How does that look like? Yep, I think that's correct. The only difference is we're not going to grab it from a returning. We're not going to put a returning in the COBOL code. So that is our int array. Now let me go ahead and renumber our source code. All right. Now let's test the floating point. Some float array. Okay, I think we're okay here, except what I'm going to do is I say array float items and int is equal to. Now I've got an int here. I probably want to create a float counter. Actually, what would be a good way of doing this? Let's see. So I'm going to go ahead and create a variable up here. Oh, here it is right here. So I create a variable up here called a float. So go ahead and create one. It's a comp2. And what I'll do is I will move just some floating point number. My an int is at 1 because remember arrays start at 1 in COBOL. I'm going to perform it 10 times and then I'm going to compute array float item. Oh, wait, what am I doing? What am I doing? I messed up my old integer one. Not too bad though. So okay, so that looks good. Okay, so I'm going to say array of an int is equal to a float, and let's multiply it by another floating point number. We're just adding data. And the an int is simply a counter to take us through the array. Okay. So now I'm going to say call some float array using by reference float array ptr. Remember, we're using the pointer, not the actual COBOL data item. The size is going to be an int, And we're going to get rid of this returning. And what I'm going to do is I'm going to comment it out for now so I can just show you that there's really a problem with this. And we have to add one more thing here. Almost forgot. I created a variable called float array sum. It's going to have it's going to return. So we're going to send that by reference. And let's make sure we change this to float array sum. All right, so I'm going to make it. Looks good. I'm going to run it. Okay, data at okay. So it looks like that's not quite right. Let's take a look at what we're doing here. Oh, I never incremented. I never did anything to a float, so all the data is going to be the same. So let's go ahead and say add one to a float. So our data in each one of those looks different, and you can see the data is now different. And I believe that this is the correct sum. So if you add 2.98449, you add all these together, you'll get 135.595. Now, just to prove my point that there's a problem with GNU COBOL, the way that I understand it, again, I would love to be proven wrong on this. Instead of saying by reference float array sum, I'm going to say returning int array sum. Nah, well, no, that should be float array sum. So returning float array sum. Oh, and I don't want to comment that out. Okay. So I'm going to say returning. And what does it say here? Begin error, send to unexpected returning. Oh, because I put a period there. And now the data is messed up. The data that is returned is 3730666944. I don't know why that's happening, but if you return a floating point number, and that floating point number that I'm returning is what I use to put into the by reference pointer variable that was sent, there's a problem. And I don't know what it is. Again, I don't like bothering developers too much, but this is a problem. And maybe I don't understand it correctly, but I can't find anything in the programmer's guide about that. So to fix that problem, I just go ahead and leave the returning out and just grab it from the by reference argument, and the number comes out correctly. And then you can always move it to a pick, a pick plus 94V30, whatever you want, however you want to format it. But we didn't do that here. All right, so integer and floating point arrays in C and C++ from COBOL. If you're wondering about the C++ thing, because we didn't really do that in this video, take a look at the end of the last video, because I show you how to do that by simply putting extern C around those functions and then put those in a CPP file and then using the G++ compiler. But also we didn't do any talking about character arrays, because we did it crazy character arrays back in the previous video. So take a look at that. Those are simple, super simple. You'll really enjoy it. And I may have mentioned earlier in the video that we were going to do a follow-on video on how to get this all to work in C++. Well, I've gotten it to work in the previous video, so take a look at that near the end about how you take all of these functions and wrap them up into a C++ wrapper. Now, whether or not you can do this, you don't actually need a wrapper. You can just call them as long as you put them into a block entitled extern C . Take a look at the end of the video for that. As for using this from like an object-oriented C++ program, that's a much larger problem. And to be fair, I've never done that before. I look forward to researching it, but I don't know if it's actually able to be done because of the way that the GNU C and C++ compilers differ so much. but we'll see. And if I am able to figure that out, I will go ahead and post another video. Until our next video, keep on coding.